oxygen. A bit more of that. I think I'll need stronger peroxide for later, Joe. Some more catalyst. But as you can see, we've got a foaming agent. I'll give it a shake. I'll do a Jamie Oliver. And it grows and grows and grows. We'll wait that, and I reckon it will go further. You can see it reacting. The catalyst speeds up the reaction. Now, in all these reactions, we've had to give the chemicals, we've either given them heat, give them a catalyst, we've had to give them a little push to get going. And this barrier that the chemicals have before they react is called an activation energy. It's a little bit like a big hill. Going up a hill, it takes a lot of energy to get to the top, doesn't it? And when you go down the hill, it's less energy because you're running down. And what a catalyst does, it takes you around the sides of the hill. So you use less energy and it's getting to the top, isn't it now? So there we go. Anybody want their teeth cleaned? With this? There you go, elephant's tooth. Yeah. One of the... Okay guys, that gets good, that one, isn't it? So we've given it energy. We said you need to give particles a bit of a push. This is one of my favourite chemicals of all time. It's called ammonium dichromate. And it's my favourite because on the bottle it says explosive. They might like explosive reactions. So it says explosive, alright. Not doing anything. We haven't given it enough energy. We haven't given it an activation energy to start a chemical reaction. So what we're going to do, we're going to give it the energy, we're going to send it over its activation energy barrier, we're going to make it, hopefully give the particles enough energy, start them to react. We can have the lights please. We're going to see if we can give these particles enough energy to react. We've got a nice little flame. There we go, just watch. Something will happen. I think we have given them enough reactions. Starts off slowly, the chemicals get their energy. Do you see anything happening? What we've got, we've made a little volcano. Out of that orange powder, made a volcano. This is quite nice, isn't it? So we've given it the action, a lot of energy, pushed the molecules over their activation energy barrier, they've started to react. They create heat, they self-perpetuate, they self-react. It's known as an autocatalysis reaction. And that will go on and on. Now I only put a little bit of orange, it's not going to go bang yet, don't worry. This one does. Okay, can I have the lights back on? Now, I only put a little bit of stuff of chemical on there. We've made quite a lot of green powder. Now in chemistry, we like to use chemicals all the time. Now this chemical compound is called chromium-3 oxide. And I can use this as a catalyst. Remember we said catalyst is a chemical that speeds up a reaction without taking part. So if I take some of the lovely fresh chromium-3, now the last 2 years guys this hasn't really worked, so it's one of those reactions that will work if it's done well. And it used to work. So we're just going to heat up this catalyst, and we've got in here a compound called ammonia. So this smells like baby's wet nappies. We'll have the lights please. Watch the tube. Thank you. Lights, please. That was lovely. That's good. First time in 2 years. I'm really pleased. Really pleased. So, as you can see, when we decompose the ammonia, on the outside, got a lot of light. We've also made a chemical called water. What we're going to turn to now is we're going to look at water. But we're not going to look at tap water. We're going to look at the elements that are in water. Water contains hydrogen and oxygen. So we are going to explore these two chemicals. Now we all know, we all need oxygen, don't we? We made oxygen by decomposing the liver, using the liver to decompose the hydrogen peroxide, and we made oxygen, and hopefully we've still got some here. Might re-glow. Yes! We've got oxygen. We've also got hydrogen. Now, where's my hydrogen? Hydrogen was used in balloons until the Hindenburg air disaster in the 1920s. What happened there was the airship basically blew up because hydrogen is extremely combustible. It can cause explosion. When you explode hydrogen, all you make is water. Now, and finally, and all we're doing is making it explode. Now, that was all well and good. But what happens if that explosion was in a confined space? Girls, you will need to move to the side. What we've got, we will have rocket fuel. When we explode fuel in a rocket, it pushes the rocket forward as the gas escapes backwards. An example of Newton's third law of motion, which says every action has an equal and opposite reaction. So what we should do is launch some rockets, shouldn't we? Okay. Chris? I'll do that after. So, right, if we're doing rockets, before every rocket goes off, what do we have? Oh, you have a countdown. So, move that way, please, guys. Now, we're going to make some bubbles later. We'll make like, but we're going to do some launches. I think we need a bit of fun. I wear these because I'm not silly. So. That was a bit of a boring one. So we won't do that one. No rocket there. Now we have another one. So, give me done. So, are you ready? 5, 4,